In this video, we're going to discuss oxidation and reduction of alcohols. Honestly, mainly we're going to talk about oxidation here, and we're going to talk about organic oxidation. This is how our food gets oxidized and we get energy from things like the oxidation of carbohydrates. So that's where we're headed with this. Organic redox is redox in the sense of gain or loss of electrons, but the thing is with organic redox, we don't really have to sit there looking at oxidation numbers and flow of electrons. That's just not where we focus our energy in terms of studying these reactions. In organic redox, we look at it a little bit differently, and it's a little bit simpler in terms of what we're looking for. Organic oxidation will increase the number of C to O bonds. So in organic redox, oxidation is where the number of C to O bonds increases and C to H bonds decreases. In reduction, it's where the number of CO bonds decreases and CH bonds increases. So these are just opposites, just like they were in, when we were looking at inorganic redox and electron transfer. These are just opposites. But the real deal is that we're going to focus on oxidizing these alcohols. And organic oxidation is simply more bonds to oxygen. So oxidation means you end up with an increased number of bonds to oxygen, much like the term sounds. And that's really all we have to focus on. So how do we do that? Well, we're going to need a strong oxidizing agent or some sort of oxidizing agent. A strong ox agent is something like sodium dichromate. So sodium dichromate could be our strong oxidizing agent. By the way, sometimes we indicate oxidizing agent with brackets and an O. And we're telling that, well, we're going to use some sort of oxidizing agent. And our sodium dichromate's formula is just Na2Cr2O7. Okay, we have some weaker oxidizing agents, and we use them in our lab, and those have the common names of Benedict's, Benedict's reagent, but we'll just call them Benedict's or the Tollens reagents. And these are weaker oxidizing agents, and so we'll talk about where you use a weak or a strong oxidizing agent. Here's the deal. We can oxidize an alcohol like this. So we've got ethanol, CH3, CH2, OH. Since that C bonded to the OH is only bonded to one other C, this is a primary alcohol, right? Our C bonded to our OH, bonded to just one other C, it's a primary alcohol. So how do primary alcohols act in an oxidizing agent? We're going to end up with, like I said, more bonds to alcohol. So we're going to copy the carbon chain. That's an important part of writing the products of oxidation, is that nothing happens to the carbon chain. So we're going to copy the CH3 and the CH2. Oh, and then I shouldn't have copied that last hydrogen, because what we're going to end up with is an aldehyde. So I'll just need to change it. We're going to end up with C double bonded to an O with an H at the end. So we're going to end up with, first, we can oxidize the primary alcohol to an aldehyde. Just made a little mistake there. And then it oxidizes even further from the aldehyde to CH3, C, all the way actually to the carboxylic acid. So we can oxidize a primary alcohol first to the aldehyde and then to the carboxylic acid. What about a secondary alcohol? Here we've got isopropanol. We've got isopropyl alcohol, or CH3, CH with an OH, and then CH3. So we've got 3 carbons in our chain. So our carbon in the center connected to our alcohol is connected to 2 other carbons. That's going to be a secondary alcohol. What do secondary alcohols do in oxidation? Well, secondary alcohols can actually oxidize with a strong oxidizing agent to a ketone. So this alcohol oxidizes to a ketone. I should have written carboxylic acid here as well. So again, primary alcohols with a strong oxidizing agent can oxidize all the way to the carboxylic acid. I like to think of them as how they go through the aldehyde to get there. Secondary alcohols oxidize to a ketone. What about tertiary alcohols? Well, if we look at tertiary alcohols, here is T-butyl alcohol or T-butanol. We've got CH3, C, CH3. Now that middle carbon is bonded to another CH3 and an OH. So that middle carbon has bonds to 1, 2, 3 other carbons along with the alcohol. So this is a tertiary carbon. When we try to oxidize that tertiary carbon, unfortunately, that carbon has 3 bonds to carbon and 1 bond to oxygen. It doesn't have room to lose a bond to hydrogen and gain a bond to oxygen. You can't lose any of those bonds to carbon. So unfortunately, nothing happens here. This one's going to be a no reaction, right? These can't be oxidized. Tertiary alcohols are just not oxidized, even with our strong sodium dichromate oxidizing agent. Okay, so I also want to talk about one last conversion. What if we just wanted to convert aldehydes to carboxylic acids? If we just wanted to do the conversion or the oxidation of an aldehyde to a carboxylic acid, that's where we would use our weak oxidizing agent. Our Benedict's or Tollens reagent would help us oxidize just an aldehyde to a carboxylic acid. So that's going to be the role of the weaker oxidizing agent. Again, the strong oxidizing agent, like the sodium dichromate, takes the alcohol through the aldehyde all the way to the carboxylic acid. So it takes a primary alcohol to a carboxylic acid, a strong one. Let's actually do this. A strong oxidizing agent takes the primary alcohol and ends up all the way at the carboxylic acid. It takes the secondary alcohol and ends up at a ketone. It takes the tertiary alcohol and can't do anything, no reaction. And again, to review, the weaker of the oxidizing agents, such as Benedict's or Tollens, are actually useful in taking aldehydes and ending at carboxylic acid. So there's a couple different ways that we could end up at a carboxylic acid if we wanted to. We could use a weak oxidizing agent on aldehyde or a strong one on a primary alcohol. So let's look at some examples. Here we've got examples all with strong oxidizing agents, our sodium dichromate or Na2Cr2O7. So that's how we recognize that, hey, we've got a strong oxide agent. And we can put that as oxygen in brackets if we want to. Okay, so the first reactant we've got is CH3, CH2, CH2. We've got a C that has 2 CH3s coming off of it, and then it's bonded to a CH, and that CH has an OH and a CH3 coming off of it. So our OH is on a carbon that is bonded to 2 other carbons. That makes it secondary. Okay, well, if you recall, secondary alcohols can go to ketones. So let's copy everything else. Let's copy CH3, CH2, CH2. The C was bonded to 2 CH3s. And then the next C is going to become our ketone because instead of an OH, it's going to have C double bonded O in it. It loses this hydrogen. So it loses an OH and it loses that hydrogen. Doesn't really lose the OH, rather. It becomes oxidized, to its ketone. But it does lose that hydrogen. We wanted to lose this bond to hydrogen, and our OH becomes our ketone. Okay, so again, we've got our secondary alcohol, we've got our strong oxidizing agent, and we oxidize to a ketone. Okay, let's try the next one. CH3, CH2, CH2, CH2OH. We've got butanol, 4 carbons and an alcohol or butanol. Now, our carbon is attached to one other carbon, our alcohol carbon. So our alcohol carbon here is attached to one other carbon. That makes it primary. Primary alcohols with our strong sodium dichromate, Na2Cr2O7. We can show how they go through the aldehyde if we want, but we have to remember to end at the carboxylic acid. So they're going to go, we're going to copy this all down, CH3, CH2, CH2, and then we're going to go, our last C is going to have a double bond O and then an H. We can go through the aldehyde, but we can't stop there. We have to make sure with our primary alcohol that we go all the way to CH3, CH2, CH2, C, double bonded to O and an O and an H. We have to make sure we go all the way to the carboxylic acid with our primary alcohol. So I showed the aldehyde here in the middle, but this would sort of be optional, you know? You really wouldn't have to. And a lot of times folks might be just interested in the endpoint, the carboxylic acid. Now let's look at the last one. We've got our cyclohexane ring, and on one carbon of the cyclohexane, there is a methyl group, and on that same carbon an OH. So that means that the carbon for the alcohol is attached to 2 other carbons in the ring and 1 in the methyl group that was on it. That carbon's already attached to 3 other carbons. It is tertiary, so unfortunately it doesn't have a hydrogen to lose. There's no way to make another bond to oxygen, and so it's a tertiary alcohol, and we cannot oxidize this, so there will be no reaction for the tertiary alcohol. So again, in oxidation of our alcohols, we're going to take our primary alcohol, go through the aldehyde all the way to the carboxylic acid with a strong oxidizing agent. We're going to take our secondary alcohol and oxidize to a ketone, and then there's no reaction on our tertiary alcohols.